Okay, so this says, consider the titration curve to the right. Let's take a look at this, and let's talk about this first before we even read the questions, okay? This is a graph, and what this graph is showing you is the change in the pH of a beaker, or more correctly, an Erlenmeyer flask throughout this lab. So here's our Erlenmeyer flask in our solution, which is either an acid or a base. And then above it, you have this thing called a burette, which looks sort of like a long graduated cylinder, but at the bottom of the graduated cylinder, there's a knob so you can let liquid come out of it. So that's what this thing is right here. So you could twist this, and then what it would do is it would allow drops of your solution that's in the burette, this is our burette, come out into the Erlenmeyer flask. All right, so that's kind of what's happening in there. Now, in this flask, we have a probe that gives you the pH also. That's where we get this graph from, okay? So in the beginning, because this is volume added, so in the beginning here, nothing from the burette has been added, so we're just measuring what's down here. So if we measure what's down here, and it's 14, right? Because of that, what is this? Is this an acid or a base? It's a base. Is it a strong base or a weak base? Strong, right? Because the pH is it can't get any stronger than 14, right? So this would be a strong base. So what do you think is going to be up here in the burette if eventually the pH goes down and it even gets into the, close to 0? It's going to be a strong acid. Good, yeah, it's an acid that's strong. So we're literally combining these things in here. All right, so that's what we're doing. We're going to combine what's in the burette with what's down here. It's an acid and a base reaction, so it's going to neutralize. But if you add extra of this, it's going to overpower this, and then it'll become acidic itself. All right, and that's what this graph is showing us. All right. Okay. Here's some other things the graph is showing us. It starts at 14, which again, strong base, right? And then as we add acid, you can see the pH dips a little bit, and then it dips a lot once it gets to around here. And this range here, one drop can actually make it jump all the way from being up here all the way down here. So when you see this vertical drop, that's our equivalence point, and that's kind of where we're looking when we're doing a titration, and that's where we want to stop. We want to actually stop it at this equivalence point if we do a good job at the lab. So this knob here, you can twist it, and you can make it so that it shoots out whatever's in the top fast or drop by drop. So when we get to the point where we're close to it, we're going to slow it down and have it go out drop by drop by drop. And I'll show you what to look for when we're doing this in the lab in a couple weeks. Okay, so the equivalence point is the middle of this vertical area, and that's why it has this 7 right here. Okay, so that's kind of what's going on with all of that. All right, let's look at the questions and see if we can answer this. So it says, consider the titration curve to the right. The titrating agent, or the titrant, is the solution in the burette. Okay, so the solution in the burette is the titrating agent. Both solutions are 0.1 molar. There's about 50 milliliters of solution to be titrated. Is the titrating solution an acid or a base? So the titrating agent is in the burette. So the burette. And I'm writing this down just so that I remember where to look. All right, so in the burette, which is this part, we already identified it's the acid. So that's great. Is the titrating agent the acid or is it a base? And we said, all right, it's a strong acid. All right, good. Is the solution to be titrated, the solution in the beaker, an acid or a base? All right, we already identified that it is a base and that it's strong. How do we know that it's a base? Well, we're starting off with a pH very high. That's how we started off figuring this out. How do we know that it's strong? That it's a 14. It's not only that it's above 7, it's all the way up to like 13 or 14. So that'll be a strong base. What's the pH at the equivalence point? This is our equivalence point. Equivalence point. So the pH there is 7. And what pH range should the indicator for this titration have? The idea here is what numbers should we kind of like be looking for it to go from one to the other. Now with this one, there's a big range in here. So what I usually do is I'll look at the equivalence point and I'll go plus or minus 1. So whatever that is, plus or minus 1. So my range would be from 6 to 8 because you want it to still be in this vertical. But you could even do with this one because it's such a large range. You could probably even do like 5 to 9 or something like that. That would still work. But again, if you always just do plus or minus 1, that's fine. And that's how you would answer these questions. So before you even look at the questions, I would identify and I would draw this out. What's in the beaker? What's in the burette? And you can just draw this really quick. It doesn't have to be as detailed as this. And then label it and then go through the questions and it should be pretty easy. All right?